Hi and welcome to my shop. Today is the 4th of October and in my shop it's going to be Magic Eye Day. Today we're going to look at the Magic Eye for this radio and sort out what I'm sure is a curious story behind this Magic Eye. I've already taken a peek at the situation and there's definitely lots to be said about it. So, but just before I do that, on the last video I went through the capacitors and did some tests on them to try to qualitatively determine what's good, what's bad, and whatnot. And I showed this thing where I measure a voltage coming out of capacitors and what I believe is not a charge voltage. So here's a capacitor. It's been clipped to my meter since then. 24 hours it's been clipped on this meter. I checked, even with the meter off, these leads have the same impedance, meter on, meter off. I'm going to turn the meter on, we're going to look at what the voltage is sitting on this capacitor, and it could be a 0. It's an experiment. Here we go. Wow, it's pretty close to a darn 0, isn't it? Okay, so we're looking at 3 millivolts. Wow, okay, I was hoping for something a lot more than that. 3 millivolts. Well, that could just be the error in the meter. So I'm going to disconnect this now. Goodness knows there can be no charge left in this capacitor. No charge at all. So that is coming from somewhere. Arguable about where. But I'm going to disconnect. Yeah, the number actually went up for a moment. Give it a moment. I'm going to reconnect and hopefully we'll see a little more here. Here we go. Okay, 10, 8, 7. So, okay, so this isn't the strongest one that I've done. I've done other capacitors that can really put out like 100 millivolts steady and power this meter at 100 millivolts. Not this guy though. So that's just another test that I've never read anything about it, that I do periodically when I'm curious about things. And in my mind, what I'm measuring or what I'm seeing is the result of moisture having gotten into the capacitor and caused some chemistry to occur. Okay, enough of that. Boys and girls, that little experiment didn't go quite as well as I had hoped. But then, you know, why do you do experiments? Follow the scientific method, right? The scientific method is not see something and try to explain it. That's not the scientific method. The scientific method is theorize, come up with some idea of what should be, then measure it, and then you've discovered if your hypothesis is correct or not. And a big element in that is precision of speech and communication. If you really want to be scientific, I'm long ways from it in here all the time. It may seem I'm taking kind of like a sciencey view of this. Maybe it looks that way. No, I'm taking a curious man's perspective on this. I'm not following a scientific method. Okay, but let's follow this method. So here we go. Magic Eye socket. In this radio, this is clipped up high in the cabinet and has its own little hole through the front of the cabinet. The Magic Eye tube at the moment has gone missing in my shop, so I can't find it, but that's okay because I'm not even sure we're even going to power it up today. So in some radios, these wires take a heck of a beating, and in fact they don't last. There's a particular kind of radio, common radio, in which this cable goes right against the rectifier tube and it always cooks out the insulation right in this area, but not this one. This one's great. Even where it goes through the radio up here, it looks fine. Things get more interesting on the other side though. So here you can see the wires coming in. There's a little knot there to keep them from going out, of course. And 4 wires coming in. So two of them power the heater. The other 2 do 2 different things. One is supplies B+ to the Magic Eye tube, and the other one is provides the signal for the grid of the Magic Eye tube, and what you put on the grid is going to cause the eye to open and close. So the idea here is you want to use the Magic Eye to essentially monitor the AVC voltage. The AVC voltage goes up and down with signal strength. The AVC voltage is developed by rectification of the signal coming out of the intermediate stage, going, well, that's what the detector does, going to the detector where it rectifies it into DC. It's a DC that's going up and down in accordance with the audio signal, And so what the radio does is it separates the DC away. You can kind of put it that way. Some radios would throw it away. Who needs it? Throw it away. It's really that AC signal you're after that's got the audio. It's the audio signal. So that's kind of cleaned up and shoved on into the audio portions of the radio. But very early on, radio engineers realized that that DC voltage can be useful. The DC voltage that builds up can be a positive voltage relative to the chassis or a negative, just depending upon which way you rectify it in the detector. If you rectify it so you develop a negative voltage, wow, you've got something really handy now. You've got a voltage that's negative relative to the chassis. Nowhere else in the radio can you develop that voltage easily without introducing another power supply or using a resistor trick in the existing power supply. You can do it that way. But this negative voltage is very useful because the negative voltage goes up and down with the signal strength. It would be a great thing if you could take this voltage, which is varying slowly with signal strength, and apply it to one of the tubes to cause its amplification to go up and down. Well, it so happens that tube engineers design tubes that are very sensitive to the bias on the grid. So if you raise and lower the bias on the grid, the amplification factor of the tube goes up and down too. That's exactly what you would need for some kind of volume control or signal strength control. So if you're new to all this and you're new to my videos and that, I'm going to tell you something else you probably never realized. You just heard it all your life and never thought about it. And that's when you're tuned in, let's say with an AM radio. So you're tuned into a nice strong signal and you're listening. And then as soon as you tune away, all you hear is a loud hiss. And when you get hiss and noise and gravelly sounds these days, when you get to the next station, as the station comes in, the hiss disappears. So I always thought, when I didn't understand what was really happening, this would be quite a while ago, when the station came in, it kind of pushed out the hiss. I mean, the hiss went away, so the station must be pushing it out. Well, that's not at all what's going on. What's going on is, when you tune into a station, there's this negative bias voltage that's developed at the detector. The negative bias voltage is then applied back to the grid, sometimes 2 or 3 tubes in a radio like this, to reduce the amplification of those tubes and calm down the amplification. So you don't have to have this in a radio. In fact, in more advanced radios, you can turn this feature off. Then the radio runs only on its volume control, although some of those radios will have another volume control called an RF control. So you begin to manually turn up and down the front end of the radio with this RF control. But in a world where people want to turn on the radio and listen to it and have it, not have to twiddle all these dials, then some automatic volume control thing is great, because you can tune in a weak station, you can tune in a strong station, you get pretty much the same volume. The detractor is in between stations. The radio essentially turns its volume right up full, and all you hear is all that noise and crackly stuff. So when I'm listening to shortwave on one of my bigger radios, I turn off the automatic volume control feature, and I work the RF control to prevent overloading. That's a very, very powerful radio I'm talking about. And then as you tune between stations, instead of this terrible, horrible hiss coming up, it's just, if you set things right, it's just silent. So you have this silence, and then you pick up a station, comes out of the silence. So that's what's really going on in the world. Quiet signal. Quiet signal. That's a much more pleasant way to listen to a radio. And if you're a radio listener, if you're a shortwave listener or something, the automatic volume control makes the radio scream at you when it's not picking up any stations. Okay, so that's enough talk about that. I think I got my point across. Now, what's that got to do with this? Well, the AVC voltage is the critical part that's driving the grid on the Magic Eye tube. The Magic Eye tube is really showing you the AVC voltage. That's really what it's doing. And in that respect, if you realize that, it can be used as a qualitative instrument, not only to help you with tuning the tuning dial, but even tuning all this stuff. You could potentially rely on a magic eye to get this done. I mean, you still need some more equipment, right? You need signal generator and the like, but it's much more of a excuse me, an instrument than it is simply an attractive feature on a radio. Now let's get down. Have I talked enough? How long have I talked now? Oh my God, 10 minutes of talk. I haven't done anything. Let's do something. So one of the first things that caught my eye when I looked in the back of this radio so many videos ago was this wire, which is standing right out, and a resistor. I'm going to take a little closer look. Let's just move this camera in a little closer. I think you should be able to see it. The wire is coming along on top of everything, soldered to the end of a resistor, which is soldered to this terminal. I didn't know what this wire was. When I first saw it, it looked to me like it was coming from here. Well, it's not coming from here. This only has these two wires. This is just a choke coil. This wire actually goes in behind and goes out and heads to the eye. It's part of the eye. So 4 wires on the eye. 2 go to heater terminals, and I can see them. This one, that's a heater terminal. I know it's a heater terminal because I can count the numbers and check in the tube book, or you can just look and see that there is a wire running from tube to tube to tube right down on the chassis. There's one down here. I don't know if you can see it, but it's running from tube to tube to tube. And that's the heater line coming through, without a doubt. So what they've done is they're powering the magic eye from the heater line that's powering these tubes too. So that's one wire here and the other black wire here getting the 6.3 volts up to the heater. Now it's the other 2 wires that are interesting. One of them is supplying B+, and I can tell you it's this one. It's this one. It comes down in behind here and hooks up to this B+ point here. Or this is a point somewhere in the B+ line. The radio's not switched on, by the way, or I'd be singing right now. So that's where the B+ is, and then so this line must be where it's getting its grid signal for the magic eye. And this resistor, I've seen other cases where he's done this. A resistor used to go to a terminal, but for some reason he's forsaken that and simply hook the wire to the end of the resistor. It's stiff enough, you know. The resistor becomes its own terminal here. It's pretty stiff. So why don't we look at the schematic now and see what the schematic recommends about wiring this magic eye. There's nothing complicated about a magic eye wiring. Okay, let's go take a look. Okay, so here we see the magic eye right here. Visio-Glow. I'm pretty sure the term magic eye was a copyrighted term or something like that. So here they call it the Visio-Glow. I like magic eye a lot better. So one thing to notice right away is this R23 here. Let's zoom in a little bit. So the way these guys work is just a little hard to understand. I'll try and explain it a bit here, but I'll probably get the explanation wrong. The way they've shown it on this diagram makes what's going on in the eye oversimplified. So you can't quite tell from looking at this diagram. If you look on the internet at other magic eye, there's lots of magic eye explanations out there. You'll see this is just a little oversimplified here. But let's go ahead and see what we can do with this. So this curved piece is the piece you look at that turns green, and that's hooked up B+ all the time. This is the B+ line up here. B+ all the time, so there's 300 volts on this thing. And when you turn on the radio and have no particular signal tuned in, the magic eye is open. So this is where I'm going to get this a little mixed up. So just listen to me and generally take in what I'm saying, but don't take the specifics too much here. So the thing is, so here's another little plate right here. So the thing is, any current flow through this tube onto this plate causes a voltage drop in this resistor, and not a small voltage drop. This is a 1,000,000 ohm resistor here. So anytime you transmit current into this, the voltage comes down.
Now this is not an AC thing. Remember, this is not the audio signal. This is a DC amplifier here. This is what's going on. Where's the DC coming from? It's coming in on the grid right here. And what is this? This is the AVC line driving the negative DC that's being derived in the detector onto grids. Now, trust me, it's going to get through this switch somehow and end up here and go onto the grid. That's a bad tube to show you too many grids. Same thing over here. ABC coming up. Trust me when I say it gets on here and follows this onto the plate. Okay, don't trust me. Don't trust me at all. I got on the wrong wire, so I got from B+. What did I do here? Okay, so the story's true, it's just the lines I picked the wrong lines. Let's pick the right lines. So go here. The DC, yeah, I'm sorry about that. We'll start here. ABC on this grid. ABC line. A resistor here to isolate things a little bit. ABC, DC flowing. Can't go here. Capacitor. Can't go here. Capacitor. Going through the coil. No problem at all. And voila. Onto the grid cap. Okay. My story worked. Good. Follow the correct line and you'll see that you can always make it back somehow onto the grid. There it is, grid cap. So this is going up and down. Ooh, this one's going up and down with the signal strength. Mostly when you're tuning is where it really shows up. And it's applied right on the grid. So let's imagine a strong radio signal produces a more negative voltage here, produces a more negative voltage here, causing less current to flow. Less current flow causes less voltage here, drop here. Less voltage drop means the voltage of this terminal is high. This high voltage is applied to this thing here, which is symbolizing a post, a pin, a thing, an electrode inside the tube. As you make this more and more positive, it drives. This is where I have trouble at this point. Yeah, you make this more and more positive, or less and less negative. That would be the way to put it. Oh, I've lost it. So I'm going to stop at this point and say, okay, so giving you some idea of what's going on in here, a very bad idea, go look on the internet and there's beautiful sites that explain this in great detail, and I'm not going to get it quite right. So I think that's as far as I'm going to go with explaining how this tube works. Because we don't really need to know exactly how it works, only out of curiosity do we need to know. What we need to know is where it's connected. That's why we're looking at it. So, okay, 2 wires going to the heater, fine. The B+ one going straight to B+. Now, in the radio, it's not hooked up here. It's hooked up, and I'm going to have to change to the other page. And we follow this line over here and pick it up on the other page here. You can see that we're on the far side of 42. Far side of the joint between 38 and 36. Or in other words, we come from the main B+ point, that's what I would call this. We go through R42. It's just a wire from there, back up here again. Just a wire, oh, yeah, up here, don't get confused. Just a wire all the way. So we're on the far side of one resistor. Which resistor was it? And make absolutely sure this magic eye is connected right, because I know it isn't already. Far side of 42. And 42 is hooked up to 38. Okay. So we want to find the 38, 42 joint point, and then on the other side of 42. I think I got it. 38, 42. 38, 42. So there's the junction point here. We want to be on the far side of 42 from the junction point. We want to be here.
we want to be connected here. That's 42, and sure enough, it's connected correctly. How do you like that? I thought this was done wrong, but it's connected correctly. It's connected here. B plus, joint, connection point, far side 42. That's it. What am I talking about? This is hooked up wrong. I noticed this too. See, this wire we just traced is down under everything. That's interesting. That means it got in there pretty early. This wire is over top of everything. Okay, let's look at the where this wire should be connected. This is the grid takeoff wire. We'll go back to the schematic here. And grid, oh, I gotta go up here, find the tube. Okay, so where's the grid go? So the grid goes straight to the ADC line out, way out in the radio. Let's track back. Okay, so we see R42, R24, oh boy, don't make that mistake. R24, I don't have these on my diagram. I never drew out this part of the radio circuit, so let's just keep going though. 42, we'll flip to the other diagram, maybe 42 shows up. Okay, wait a minute, let me just make sure I'm not, oh there we are, there it is, 24, it does show up. Did I say 42 again? Oh boy, slapped me in the head. So 42, and here we're basically coming the rectified signal is available here. So we have sort of the raw AVC voltage developing here. It'd be full of RF and stuff like that. This guy's trying to knock out RF, probably this guy too, trying to knock it out. So we get just a varying DC voltage here with the audio on top of it. The audio is fed through this down here, back up here, and into the bottom, what I would call the top of the volume control, the ground being the bottom. So this is where a lot of action happens right in here, where you have the RF done away with, you have the audio freed up from the DC that's coming along with it, the DC directed off into the radio to be used as a volume control opportunity, automatic volume control opportunity. You know, I like running over this stuff. I'm here alone in my shop. You know, you actually aren't here with me, but I do like running over this stuff because every time I explain it, I get it clearer and clearer in my own mind. Well, it feels that way. Feels like that. We got to find this R24, and then we should find. So maybe this is maybe that resistor hanging out there is R24. That doesn't make sense. There's no resistor in the Magic Eye circuit. The grid circuit, there's nothing. Why is there a resistor there's a resistor hanging on the end of the wire in the radio? Let's see where this wire goes in the radio. Secretly, I've known the whole time where this is going because I found this last night. I just got too curious and couldn't stay out of here. Wire comes along, goes through the resistor and connects to the terminal here. This is the terminal on the detector tube. Terminal number 1, 2, 3, 4 and 5. Yeah, wait a minute. 4 and 5. 4 and 5 are tied together. And there's one wire leaving from it, heading up into this coil, into the noisemaker coil. So, pins 4 and 5 on a on the detector tube. Detector tube is a 6Q7. 4 and 5 on the 6Q7. LMNOP Q, LMNOPQ 6 SQ7. Wait a minute. QRS. Oh man. So 6S. 6S. The S stands for single-ended. 6Q7. Twin diode high mu triode. Twin diode is the two diodes that are used for detection. There they are, pictured right there. I don't know if you can really see this or not in there, but in here are two little plates showing off the cathode, and they're hooked up to 4 and 5. 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 Let's take a look at the schematic at how this magic eye is actually connected in this radio. And then we can start asking lots of questions. So a schematic shows the grid lead connected to the AVC line, but in fact, and I'm so sorry, this is split on 2 pages. Past R24, past R24, it's hooked up right here. So off of here is a little resistor. It's not little, it's almost, it's an odd one. It's 9.3 megohms. 10 megohms. You have a 10 megohm, what I think is a 10 megohm resistor off of here, and then to the grid of the magic eye. So this is really hard to explain why it's like this. The owner and I had a couple of chats around this. What's the history of this radio? What has happened? I came up with the idea that this isn't the original chassis, that this chassis must have come from another radio that didn't have the magic eye option, maybe a lesser version of the radio that's here in my shop, where they didn't have the magic eye, and maybe they didn't even have the extra amplifier. Maybe they used the 245s in the receiver here to drive the speaker. Maybe. And so in the shop, somebody grabbed the chassis from that, swapped it in to this radio, and then wired in a magic eye themselves, because there isn't one in the lesser version. So the problem with that, as the owner of this radio pointed out, is that this is the top of the line model here, and there is no other radio that uses the same chassis. Now, we gotta take everything with a grain of salt, everything that's said by anybody these days. Maybe there is. So that's one possibility. This chassis is actually not original, and the magic eye was added in to make it have the same features as the original. And the magic eye got added in wrong? Yeah, now what? Why would that be? So the history of magic eyes in repair shops is they would buy the magic eye socket, wires, and the secret 1 million ohm resistor that's in the socket as a thing. They would buy from a supplier, a manufacturer. You might have 10 of these sitting on the shop. Along comes a radio, comes in. This is a more likely story. And the first thing they do is they find out the 1 million ohm resistor. That resistor on here is this one right here. R23, 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 million ohms. The 1 million ohm resistor is tucked right inside the socket. Why do they do that? Because then you only need 4 wires back into the radio. If you were to place this component in the radio, you'd have to send a wire back from here in the radio. 5 wires, 3 cents a radio. Oh my God, 3 cents a radio. Change in price? Hey, they won't sell any of these radios. So the cheap way to go, and this is actually very convenient. This is tucked right in the socket, and that's why you can have these things on the shelf, yank them off. You can even install these things in radios that don't even have one. Never had one. Never intended to have one. You could buy these in their own little box, and you'd stick it on top of your radio and run the 4 wires back into the radio and hook them up to the heater, heat it up, 1 to B plus, drive the high voltage, and then you gotta pick off a signal to apply to the grid. So is that what happened here? Some guy cut out the old one because this 1 million ohm resistor, I'm going to have to explain this. I got to explain this a little better. Why not just replace this resistor? I'm going to show you why. Let's look back at the radio here. Because the 1 million ohm resistor is inside here. Now I've done 3 or 4 of these. This resistor is almost always bad in an older radio. And you hear the big huh. These are not built to be opened. They are one way. They're built one way. And I guess the idea was, should that resistor ever conk out, just put another one in and throw this away. From a repair shop point of view, where the customer is going to pay the cost of the thing, why not? Because getting at that resistor in here, well, it's a sad tale you're probably going to see a little later in this video when I go after it. How do I know the resistor is bad? That's in here. Experience, but that's no guarantee. So the resistor is between pins 2 and 4. All I got to do is look for 2 pins that are have one pin in between, and they come out with 1,000,000 ohms here. Put this on the resistance, and I look in the socket. This is a little tricky to do. I'd say these 2 pins are slightly bigger. Now, you know what? Look at that. There's a little orange. Oh, Jim. Okay. If you look at that, there's a little orange dot there. Yeah, you can kind of see it in the, looks like a piece of dirt or something. A little orange dot. So that's marking the 2 larger heater pins. This would be pin 1. Pin 1, between pins 2 and 4 should be the resistors. That'd be 1, 2, and 4. What do we get? Oh, I thought I saw something. Let's just make sure this is easy to get this wrong if you like. Oh, there we go. Must be a capacitor involved somehow. It looks like it's going to settle in around 5. That's not hitting for 1. That's definitely not hitting for 1 megohm. That's hitting for 5 megohms. So, as is almost always the case, that resistor is bad, and it has to be, at the very least, there's really only one way to fix the situation here. That's to break into this thing. Well, so that's down the road. I don't want to do that right now. I want to get back to what has happened here. Now, the reason I want to analyze this is because the fellow who worked on this radio was no idiot, that's for sure. He knew a lot of stuff, but just like me, he can't know everything. And there'd be some areas of his knowledge through experience and other, edificational things he's done, he'd be very smart about, just like me. But then there's other parts. You've just never been dragged into that other part until now, let's say. And you don't know what's going on there. So perhaps, although it's hard to believe that's true of a magic eye, my guess is the guy did the standard thing. He pulled out the old one, and when he went to shove the new one in, he couldn't remember where the old one came from. It's possible it was a shop that had no schematics. Having a set of schematics for all these radios was an expensive thing. The better shops would definitely have books of schematics, and they would have a service which would send them every year updates for the latest schematics for the newest radios. A big, well-operating shop. The smaller shops, they can't afford it. So guys are winging it. Oh my God, I can't imagine how they could do this work. That's hard to believe, isn't it? You think, wow, you couldn't get anywhere, but so if that's his thinking, we'll do the standard thing. The standard thing is, this is the other problem. The standard thing is to hook this up to the AVC line out where the tubes are, not back where the right on the detector. This is a radio guy would look at this just like I'm looking at it and go, wow, you know what, this is going to disturb this part of the circuit. This is going to detract. This is not the place to hook up something. In fact, they use resistors to kind of isolate away other parts of the radio from this that are hooked up to it. So the AVC line comes down, goes through resistors, some of them fairly big, to kind of get isolated away from this in a way. It's also part of the filtering of the RF and all that kind of stuff. So where he's got this connected, there's going to be RF on this wire. Is that a bad thing? I probably not for the Magic Eye. Probably makes no difference with the Magic Eye. But what it would do is affect the detector circuit. And what would it sound like? What would it do to it? Weaken it? Introduce noise? And perhaps distortion. Perhaps distortion. There's not going to be much of any current flow on this. That's why he's had to put such a large resistor here to make a difference, because it's just going to a grid, which is basically an open wire with a tiny capacitor at the end. That's kind of the way to look at it. The inter-tube electrode capacitance being that little capacitor at the end. So I think, you know, no matter how it seems to me we just need to move this wire to the right spot and we're done. The right spot being the other side of 24. So 24. Where is 24? Okay, so we're looking at the left side of the schematic right over here. So we know the Magic Eye proper connection is past R24 on this line. And we know where this point is, so this is where we're going to start, right here. So that point, let me see if I can continue to use this camera here. That point so we see these two shielded wires here. Two shielded wires, so that's going out and back. I believe it was to the volume control, I believe. So it looks like this one connects right away to a capacitor and resistor. Doesn't that look familiar? And then it comes over to this terminal here to connect to what? Nothing. So it's going from here through this capacitor and resistor. Now let me look up at the so there we are. So it's coming out of the wire there, right where my cursor is sitting. Right, coming out of the wire, going through this resistor capacitor combination, then to a split, one with another capacitor across it. So hard to see. It's on this wire. Oh, it goes straight down into a coil. Oh, the picture's gotten a lot bigger suddenly. Oh, okay, explanation's coming. The guy changed out this coil, this IF coil, and in doing that, even more substantial changes occurred to the wiring in here. This is the coil that sings. So he's done this with the Magic Eye because he did that with the coil. We got to verify this coil. Now the radio is working, so it's got to be mostly correct. But I got to verify what has happened to this coil. Oh my gosh! And how many? What do we got? 1, 2. Thank God, there's only 4 wires coming out. So we know 2 are primary, 2 are secondary. So, okay, so that means, you see? Does anybody see? Do you see? Wow, there's a lot of stuff here to see. This wire's not soldered, is it? Yeah, it is soldered, but just barely. Just don't talk about other people soldering, Jim. You're not the king of soldering, that's for sure. Well, rather than I'll stop the camera, burn some brain cells on this, and then we'll see what I get out of it. I got lots of brain cells, you know. I still got lots left. Of course, you know, the fewer you have, the less you realize you have fewer. Okay, let me spend a little time on that. Okay, let's take a look at what's going on here. So for the first time in my mind, it's suddenly struck me that
coil, or the transformer here that's been replaced, is of course the last one in the IF string. It's the one that feeds the detector. It's all starting to make a little more sense here. So now we got to ask a lot of questions. What happened to this capacitor, these resistors? What has happened here? What has happened? Oh boy. And this guy sings. He makes a sound. Only on the AM band. So what I was thinking, even before I started this video this morning, is that wire that's coming off here with the resistor off to the eye is the one that's upsetting this circuit and causing it to sing. But now I realize, no, it's a lot more to it here. A lot more to it. So I think what I'm going to do is I'm going to get out a piece of paper and a pencil. I'm going to trace out all this stuff here and see what it is for real. That's what I got to do again. Okay. Okay, well, the situation has become really odd. Let me just drop this camera here for now. Yes, sirree. So I'm finding a very significant variation from the schematic. So if we just look at the schematic there. So what I've done is I've been able to find these two guys, their sizes check out. But what happens next, I believe all this is missing. I believe all this is missing. And a wire goes right from here, right to there. Where? Right into the, right from, really from the secondary is really the way to put it. This capacitor exists? I'm not sure yet. I just stopped at this point and decided to turn on the camera and share the pain. So let's just review this, because whenever I find some variation like this, the first thing I think is I'm just not getting it right. I just haven't seen something yet. So we're going to start right at this point and try to work our way forward again. Okay. And so I'm just thinking I can't really employ, well, I can. I'll employ the close-up camera when it becomes necessary, but I think you can probably follow most of this from where you are. So we're starting with this capacitor and resistor right here. So here's the end of the shielded wire coming into the bottom of this capacitor and resistor. And where we are on the schematic, let me just keep my finger there, is we are right here. The wire coming into the bottom of the resistor and capacitor. We go to the other side. What I should find now is two resistors. Okay, let's bring in Mr. Close-Up Camera here, because I want to be absolutely sure about what I'm doing. Okay, so we're coming from the wire down here into this end, coming through. We should find two resistors. What we actually find in here, is this wire. There's nothing else attached down here. There's nothing going anywhere hidden from view. Absolutely. All that's connected here is a wire. So on the other end of the wire, we should find those resistors. But this wire just goes down into the coil. Where are those resistors? What happened to them? I think they're gone. I think there's a whole section missing here. Okay, so I'm partway through trying to sort this out. It's really not easily done. So I've taken the extraordinary step of printing the entire schematic. And as far as this might be to see in here, the red lines are what I'm determining to be the case. So I don't think there's any way you can plug a phono into this. There's these shielded cables and shielded wires, in fact, go up to the volume control. That's why the big X is here. So in effect, this is joined right here in this radio. So all these check-marked components exist. Everything is normal coming up this way. from here. Going the other way. Now, what about all this stuff? I can't find any of it. Some of this might... no, I was going to say some of this might be to compensate, compensate for the cartridge, which envisions being plugged in here. But in fact, the compensation's over here. There's a capacitor over here. So this is all about the radio signal coming down this wire. This is missing, this is missing, this is missing, and I haven't found this yet. And I just thought I'd show you that, because if all this stuff is missing, that's got to be a problem. But it does leave the magic eye. Remember magic eye? This is all about the magic eye. It does mean the magic eye connection here may be the same as the connection anywhere along the AVC line, because the resistor network has been removed. So it could be this connection made here. It doesn't matter if you make it here. And you know what's interesting? The value, I wonder if this resistor is an attempt to do this one. Because you know what? R24, I've got it right on the sheet here. I think it is. R24 is a megohm. And this resistor that was put in here is, let me check again, brown. Or I'm sure is black, green, 1 million. So this is supposed to be R24, but it's only hooked up to here. So how does the rest of the AVC get out here? If this resistor is missing, there must be an alternative connection made, or there's no AVC out in this part of the radio. Well, that would be a bad thing. I measured AVC, but I picked it off. Where did I pick it off? Did I pick it off the volume control? I don't think I ever tried to see if there's any AVC on these tubes. The problem with no AVC is you probably produce too high of a signal for strong radio stations. Since the signal's not being reduced in these earlier tubes, it comes through full power. It's probably too much for some of these tubes to eat. It's just gotten out of control. And you'd find you'd have to have the volume control extremely low all the time, because the rest of the radio is blasting away. If this were quieted down a bit, then you'd crank up the volume control. And this radio, the volume control is hardly turned up now to get a lot of volume. Bearing in mind, I'm not playing the radio through its regular amplifier and all that stuff, so I can't really accept that. And by the way, the other day I moved the tone control and went, this doesn't do anything. Well, the reason it doesn't do anything is because we're listening ahead of the tone control when I've got this hooked up into my audio system. So this will probably work fine when it's hooked up to its proper amplifier. A little aside there. Now back to this problem. What am I going to do? I have to prove R24 is this, and then I got to get it into a better position, because it's supposed to be in the way of the AVC voltage all the way down through these tubes. Okay, I think I'm starting to piece it together here. So what could have happened is the last guy working on this may have disabled the AVC from the front end of the radio and not really realized what he had done. It's possible. And this is not exactly the right size resistor, it's just really close. As if he didn't have a megohm, so he stuck this in, 930 or whatever it is. What is it? What was it? Because it's white. What have I got here? I must have done this one. White, orange. What is that? White. I did this before, didn't I? Well, that's got to be white. Orange is 3. 93. So it's 9.3. It's 10 megohms. It's 10 megohms. It's not 1 megohm. Well. Well, I'm going to stop again and think some more about this. Am I going to have to restore the missing circuitry? Is the missing circuitry gone because it's gone by accident? Or is it gone because once this coil was put in here, things had to be done this way forever? And why did he have to change this coil anyway? Let's just take a look at that question for a minute, because that's not easy to answer. Like, oh, well, because the coil burned out. It got too heavy a current through it. How can the coil get too heavy a current through it? Is that even possible? So the coil in question would most likely be the primary side of this. So what could drive a heavy current through this coil and burn it out? A failed capacitor shorting on the far side. But there's no capacitor. There's no capacitor here. So what about this guy fails? No, that's not going to burn this coil out. And if this leg comes open and goes to ground, well, even that wouldn't burn it out. It's a capacitor. So how do you burn this coil out? So I don't know how you burn out this side of the coil, the primary side. You have to have a whopping current going through this tube to burn this coil out. It's possible. Something went wrong. This tube chucked a lot of current in there and it burned it out, and the guy sorted all this out. The cause of the heavy current, some bad capacitor over here, I don't know. So what about the secondary side? The only reason I can imagine somebody would go through the unbelievable trouble of trying to stick a different coil in here, in this radio, is because the coils were burned beyond all hope. A coil. So what about the secondary side? Now, how can that burn out? Let's see. This is hooked up to these diodes. So what would happen if, let's say, this resistor, this capacitor, which appears to be missing now, were shorted to ground? You have a short here. Put a short here. Then you've got a signal being rectified, and it's just all that's available will flow. All possible stuff will flow. So how much current can you get in this kind of circuit? I don't know. Could it be enough to burn out this coil? I don't know. Probably. So we could assume that's what happened. This capacitor shorted. It burned this coil out. Now, why wouldn't he just, replace the burned out, the shorted capacitor, and bring in a new coil like he did, a new transformer, and hook up the 4 wires exactly as it was? Where would all these go? Are they hooked up to the coil, so when the coil goes, they go? No, these are all in the radio, and somewhere in the radio. They were. Probably on this terminal strip. Oh my gosh. So I have to get my head clear on what am I going to try to do. I think it comes back to trying to make sure this resistor here or not, R24. I must go and hunt. I got to hunt on. You know what else is really weird here? There is no connection between here and back here that I found. This wire is missing. These resistors are missing. This whole line is missing. I haven't found this resistor. That capacitor is missing. How the heck does the signal get? Well, it goes back to there being no AVC in the radio. The whole AVC circuit is gone. Now, I can prove that out. How can I prove that out? Okay, new theory. And I'm going to go eat lunch. There is no AVC connection to the front of the radio. It's been overlooked, removed, eliminated, buggered up, whatever the word is for it. So what I would do, if that's true, that's my hypothesis, then I should be able to play the radio, tune in signals, find the AVC voltage going up and down on this line here, but not find the same effect on the two grids back here. Which ones? It's going to be the 6K7, the 6A8, and maybe, why would they bring it all the way over here? Maybe including the first 6K7 RF tube. But for sure these two, I should be able to turn the radio on and watch the AVC voltage go up and down on, let's say, this tube with signal. And if it doesn't, then another chapter is going to be opened. Another chapter? Not another chapter. Yeah, this diagram now, this shows the parts I can't find. I can't find this capacitor, I can't find this resistor, I can't find this resistor or this capacitor or that resistor. This being the one that conveys the AVC back onto the other guys. I don't know. I made it to lunch, so that's what I'm going to do. I'm going to have lunch, come down, look at this with in a refueled state, and then make some decisions about what to try next, including the test I just proposed. What's for lunch? Okay, I think I'm ready. Now you might already hear a little bit of a hum. I think that's from the connection between the radio and the video system. The radio's not on yet. If I turn up the sound here, you hear that hum. I can't get rid of it. We're not going to worry about it because this isn't about what the radio sounds like. This is about the AVC voltage, and is it present where it should be in the radio? In two places. One is right near the detector and the other one is out on one of the grids of the tubes. So to do the grid of the tube, I have a clip lead. It's not particularly obvious here. This clip lead right here, which is just clipped on some plastic here to hold it, goes around the back and picks off an appropriate grid cap. So we should see AVC on this. And my plan here is to use this meter and I have at the ready this one in case I need it. I'm going to use the indicating meter here. Okay, I think I got the camera angle sorted out here, so we're going to check here, check here, check here. We're going to tune, so I'm going to be checking here. I'm going to tune with my other hand. Got my hand in front of the meter again, but I can do this. I think I can get away with this. Good enough. Okay, so the signal generator is plenty warmed up. It's on 1800. That sounds a little high. Let's put this in the band. 1200. Okay, so somewhere around the middle of the AM band we should pick this up. That's why we got to hear it for a while. Once we have it tuned in, we know we have it tuned in, then we can stop listening to it. Just watch the meters. Meter. Okay, I think we're ready to go. Let me just kind of hesitate here for a moment. Okay, there we go. All looks good. Where's my thermal viewer? Is it kicking around in here still? I use that thing all over my house. All kinds of weird stuff. I appear to have lost it. Okay, won't worry about that. Okay, we'll put a little volume on the radio here. Okay, now I'll turn up the volume on the soundboards here. Sounds a little like a radio. Now, let me see if I can get the... it's easier for me to tune the signal generator than to tune the radio, in fact. So let's just get this guy tuned in here. Fairly strong signal. I have no idea where the radio is tuned right now. Okay, maybe it's down here. Okay, so that's the intermediate frequency. We can use this if we have to. Let's see if we can find it. There's the real one. Okay, turn it down. Down. Good chance for me to check my volume levels here. Let's do that quickly. So I'm watching this meter. I'm actually watching my computer meter. I didn't get anywhere near it. Good. So, about the time the video audio is getting saturated, all my indicating meters are pin solid. So, okay, why am I doing that? Because this is a good opportunity to calibrate all these meters. So, okay, we're hearing it. It's right near this noise here. Let's just see if we can go a little further this way. Quieter spot. That's much better. Okay, now the question is there ABC showing up on the meter? So first, we will check where there should be some. Okay, watching that meter down there. A little tiny amount. Okay, what I'm going to do is I'm going to vary the signal strength of the signal the radio is receiving, and we should see this go up and down in accordance with it. Now, the question is, does that happen with this clip lead? Now, this might kill the radio. Nope, it didn't kill the radio. So it looks like there's a tiny amount there. Nope, it didn't change the meter. Now we'll turn it up. The meter should do the same thing. Ha! How do you like that, eh? So the meter's not moving. Now, how certain am I of this test? Let me just verify the other end of this clip lead here. Do it this way. There it is. It's on the second. It's on the second IF. Oh, you know what? I may be on a tube that isn't controlled. Second one. I think I'm on a tube that's not controlled. Okay, so let me move it. Move it to the other tube here. Oh, wait a minute. I am on the first. I'm on the first. Thought it was on the second. I'm on the first. That guy's controlled. So all indications are there's no AVC, and if there's no AVC, there's probably no bias, although some of these tubes had cathode bias. Okay, hey, what about the magic eye? Let's take a look at that. Now, a little hard. Yeah, you can actually see some of the green in it. Let me just douse some lights here and see if we can get a little more greenage. Oh, that looks nice now. Now, so the question is it, here, I just need something to hold it up a little better. There we are. So you can see the, it's indicating no signal. Yeah, I'm gonna have to, okay, I may bump the camera here. I'm gonna turn up the signal generator.
output. Oh yeah, look at that eye go. It's hard for me to see it. Wow. Huh. Okay, I'm a little surprised to see that. That was terribly awkward for me. Let me try again here. It's tuning in and out. I'm going to raise the signal level. Tune in and out. Wow, it's hard to complain about that. Huh. I'm following in the footsteps of somebody pretty clever. So, what to think now? Let me just review all the findings here. Turn this off before I get myself in trouble. So, there, get rid of that little hum sound. So, what do we got here with this radio? We got a magic eye that appears to work. In fact, it's very sensitive. It's almost too sensitive in a way. That was an uncalibrated test I did. I really don't know how much signal level I was putting into the radio, but it wasn't that much. So the radio sensitivity is very high. No surprise, no AVC on the front end is what it appears like now. So the front end is maximum amplification all the time. So my options here are leave it all the way it is. Look at some way to improve on the situation that's here now. So he's got a resistor here. Is that the right resistor? There appears to be a RF killing capacitor missing in the circuit. Maybe I can add that in. And then there appears to be just, I'm going to guess, kind of overlooked. And that's the AVC connection into the front end tube seems to be missing. So I can probably come up with some way to restore that. So those are the things for the magic eye. So I think what I'm going to do is I'm going to stop at this point. This will be the video. I'll post it as is. Everybody can have a shot at wondering what has gone on with this radio. And then on the next session, is it necessary to make any changes to the eye yet? Is there anything compelling me to do that? I think there is, frankly. I really think there is. I think what I need to do is restore the AVC to the front end and then move this connection from where it is now, where it may be causing some problems, to where it really should be, where it's really watching the AVC voltage that's going right to the grids of the tubes. So that would be number one, restore the AVC to the front end. Number two, re-establish the connection for the magic eye. And then number three, consider the circuit ramifications of the changes that have been made, and the changes really amount to just dropping. Did I show you this? Maybe I didn't show you this. So what's in red here, if I showed you this already, I'm sorry. What's in red here is missing. I think I did show you this. That's missing, that's missing, that's missing, that's missing, that's missing. That's the killer RF capacitor that's missing. Okay, I'll ponder these things. You know, maybe it's a case of a guy who knows an awful lot, and he just got into a schmozzle here and discovered that when he hooked the eye up to its proper spot, it wouldn't work, and he couldn't sort out why. He was sure he'd reconnected the AVC, but in fact he hadn't. And maybe he took tests and did the tests wrong, and you know, I've done this kind of stuff, and you just get more and more convincing evidence of something that's not true. Finally, you're totally convinced, and you scratch your head, what am I going to do? So he decides, I can't make the eye work, I'm going to stick it here, because I know for sure it's here. Now, this is the same guy who did all this work on this transformer. Plus, another problem, transformer singing. I didn't really notice it today. That's interesting in itself. Perhaps that capacitor would put in place, the singing would go away. Or is this guy smart enough to know better than to put that capacitor there?
He didn't put it there because he knew the radio would explode. I don't know. I'll have to think some more about this and think more about it. Thanks for watching, and I hope you're getting a kick out of this. This is one heck of a radio, one heck of a journey in this radio. So we'll see you on the next video.